Please tell me you worked on this problem. You gave it a good go, productively struggled, solved it, whatever you did. I hope so. And you thought about your thinking. Notice, if a student was to have a profound understanding of the mathematics needed to solve this problem, what would it entail? What I mean by that is not that they remembered how to do it, mimicked an algorithm, but they were really thinking deeply about the meaning of fraction to solve the problem. What would that look like? Well, maybe it would look like this. Now, what I'm about to show does not mean that you had to do it just like this. You know how I think fluency involves flexibility. I totally acknowledge it. There's probably lots of ways. And again, if you were in the classroom and all the students were around the whiteboards in my classroom working on this, we might see a lot of ways of thinking to solve this problem, not just mine. I'm sharing mine just to emphasize the role of the idea of fraction. Remember why we're here. We're unpacking fraction ideas, thinking about what a fraction means so that we can do meaningful work with fractions and maybe tackle the frustrations that we see in math education about fractions. So that's what this is about. Please don't think, oh, I didn't do it that way. Maybe your way is good too. Hey, if there's something you want to share with me, share it with me. That'd be great. All right, here's a way to think about it though. First of all, the 6,070 was 5/7 the price of a car. So you might think about this. Suppose this kind of a number line represents the price of the car. Well, the first thing we might do is break that up into, let's see, 1, 2, 3, 4, 5, 6, 7 equal parts. Cutting. So I took a whole line segment, cut it up into 7 equal parts just as a way for me to think about this problem. Maybe you did it with rectangles, that's fine. But I cut this thing up into 7 equal parts. Each one of these is a 1/7. That's what a 1/7 is. It's 1/7 of the whole price of the car. Now, what I had in my problem was, 5/7. Now I need a copy. So I need my 1, 2, 3, 4, 5, 5/7. So look down here. Boom. This is 5/7. There's 1/7, 2/7, 3/7, 4/7, 5/7. This thing right here is the length of 5/7, the price of the car. Now, 6,070 was the number. So can you imagine? Let me get this. 6,070 was 5/7 the price. So I'm going to take those. I think I have it here. I'm going to take those 5/7. Notice 1 7, 2 7, 3 7, 4 7, 5 7. I stopped it short. Here's 6 7 7 7. But this is 6,070. So if this whole thing right there is 6,070, then how much would go into each one? That is, what would each one of these 1/7 be? If 6,070 is 5 of the 1/7, then what would each one of those be? Well, we're dividing. Do you see the division happening here? We're taking 6,070 and equally dispersing it, putting it into groups, and we're going to see how much is in each group. So 6,070 divided by 5 is how much is going to go in each group. I think I have that. Yeah, there we go. 6,070 represents 1/7 the price of the car. So there's 1/7, there's 1/7, there's 1/7, there's 1/7, there's 1/7, there's 5/7, and then 6/7, 7/7. And so if I took the 6,070 divided by 5 and copied that 7 times, I would have the price of the car. Yeah. I don't think I have it on this slide, so let's just make sure you have the correct result here. What's 6? Let me try that again. What's 6,070 divided by 5? So each one of these, 6,070 divided by 5 is 1214. So each one of these is 1214. Which means each one of these is 1214. I won't do them all. But I have 7 copies of those 1214s, so let's find out what that is. What's 1,214 times 7? 8498. So the price of the car was $84.98. All right, that is it. Now, what I want to emphasize here is cutting and copying. You may have a different approach, but do you see the cutting and the copying? And in fact, let me clean this up a little bit. I want you to see one more thing. Mentioned this in the previous video, but here's an interesting piece. Up here, those little fractions are 1/7 because I took the whole and cut it up into 7 equal parts. So each one of those is a 1/7. And there's 7 1/7. There's 4, 5, 6, 7. 7 1/7 make a whole. Well, down here, I wanted to represent 5 of those 1/7. So this is 1/7, 1/7, 1/7, 1/7. Oh my goodness. See what happens when you try to go fast? Each one of these is a 1/7, but watch this. If you thought of this as the whole, and you cut that up into 5 equal pieces, remember we had 5/7, then this is 1/5. So once again, 1/5 equals 1/7. Dramatic pause. Not really. 1/5 of the $6,070 is the same as 1/7 of the total price of the car. So visually, this is why fractions are let me say it this way. This is why fractions are awesome. We have this flexibility. We can think of that same amount as a 1/5 of the 6,070, and we can likewise think of it as 1/7 of the whole. It's 1/5 of the 6,070, but it's 1/7 of the whole price of the car. This is an important moment. We must work to make this idea okay for students to have success as they continue on with fraction addition, subtraction, multiplication, and division. Keep working on it.